Hello guys, we're gonna go over problem 9. So in this problem, it talks about, so we're given a dance group where there's 25 boys and 19 girls. So every week, 2 more boys and 3 more girls join the group. How many weeks will there be the same number of boys as girls in the dance group? So we are start off with 25 boys. Okay, we start off with 25 boys and 19 girls. Okay, they over each week there would be 2 more boys added to the boys group per week. For the girls, 3 girls would be added per week. So what can we deduce? What can we draw from this? First is that the number of boys is greater than the number of girls, right? Second is that the growth rate is higher for girls than boys. So every week, 3 girls are added to the girls group, whereas for the boys, 2 boys are added to the boys group every week. So you can imagine, just because there's a difference in growth rate for the girls and boys, that the girls growth rate is higher, that at some point the number of girls would equal the number of boys. So how do we model this? Well, so let's maybe we could, it's a good idea to come up with some sort of variable, or that stands for the number of weeks. So let t be the number of weeks. Alright, so what is the number of boys at t week? Well, the number of boys are going to be start off with 25 boys, right? Plus 2 boys per week. And then times time. So this would be the total number of boys at t week, where t is the number of week. Similarly, the number of girls at t week would be 19 girls plus 3 girls times t, where t is the number of week. There is a value such that t equals to t star, where t star is a constant, right? Such that they have to be equal. So this is what we want to find. So what we could do is just eliminate these boys and girls symbols, and we could just say maybe, okay, the total number of boys has to be equal to the total number of girls at some t equals to t star, right? So 25 plus 2 times t, this is the total number of boys at t week, has to be equal to 19 plus 3 times t. We need to find the value of t. If we can find the value of t, then we know the precise week in which the total number of boys has to be equal to the total number of girls at this whatever t equals to 1. So, well, why don't we subtract the 2t from both sides, and subtract 19 from both sides. 25 minusing 19, 3t minusing 2t. On the left side is going to be 6. On the right side is going to be 1t. Well, that's just the same as t. So on the 6th week, the number of girls would equal the number of boys. So the answer is, how many weeks will there be the same number of boys as girls in the dance group? The answer is A, 6. So Peter shared a bar of chocolate. First, he broke off a roll with 5 pieces for his brother. So imagine a chocolate bar. Okay. So he broke off the roll with 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 pieces. So this part is to his brother. So this is okay. Then he broke off a column with 7 pieces for his sister. So imagine that this piece is out, right? It's out. So imagine this is our column. He broke off this column for his sister. And how many pieces are here? He's broke off a column with 7 pieces for his sister. So let's draw 7 pieces. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 pieces. How many pieces were there in the entire bar of chocolate? So if we draw it this way, we can kind of see how many pieces of chocolate are there in the entire chocolate bar. Okay, so how many columns are there? Right? So we see that there is 1, 2, 3, 4, 5. So there's 5 columns. How many rows are there? So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 rows. And so the total number of chocolate pieces that compose a chocolate bar is going to be 8 times 5, which is 40. And this would be D. Okay, this is problem 11. A farmer has 30 cows, some chicken, and no other animal. A total number of chickens' legs is equal to the total number of cows' legs. How many animals does the farm have? So this problem, what are we trying to get? It's trying to get how many animals does the farm have? How many animals does the farm have? So what kind of animal are there in this farm? Right? From looking at the problem, there is cows, there is some chicken, but no other animal. So it's going to be cows and chicken. So we want to know the total number of cows and the total number of chicken. We want to know the total number of both these type of animals other in the farm. It's given to us that there is 30 cows. So there's 30 cows here. But the question is, how many chickens are there? We don't know. So we are told that the total number of chicken legs is equal to the total number of cow legs. Well, but we know that chicken has 2 legs, right? Chicken has 2 legs. 2 legs. And cows has 4 legs. So that means that, okay, if there are 30 cows and then each cow has 4 legs, then the total number of legs the cow have in total is going to be 30 times 4. This would be the total number of legs that the cow have, right? Just the number of cows times how much legs each cow have is going to be 30 times 4. But we are told that the total number of chicken legs equals to the total number of cow's legs. So, but we don't know what the number of chicken is. So let's label this X. X denote the number of chicken. If X represents the number of chicken, X times 2 would be the total number of legs the chicken has. But we know that the total number of legs the chicken has to be equal to the total number of legs the cow has. So that means that it's going to be 2 times X, where 2 stands for the number of legs that each chicken have, and X stands for the number of chickens there are. And, this is going to be multiplication. Divide both sides by 2. And this is going to be 4 times, this is the same as 30 times 2, because you can divide 2 into 4. That's 60. So there's 60 chickens. So now we know that there are 60 chickens and 30 cows. Remember, the question asks how many animals does the farm have? And there is only chicken and cows in this farm. There's no other animal. So it's going to be the total number of cows, which is 30, and the number of chicken, which is 60, 90. It would be B. Hello guys, this is problem 12. A picture X is paired with picture Y. Which of the following picture is paired with picture G? So it's saying that X and Y is paired at somehow. Can anyone notice what is the relationship between X and Y? Notice that if in the top right corner, if it is black, then correspondingly in the white square, this part, the top right corner is white. So suppose that, let's say this is X and this is Y. Suppose instead of 4 by 4 square, we have a 2 by 2 square. Suppose that X has this thing shaded. Then the period picture Y is such that this part is shaded. So I hope this is clear. Okay. So now, in some sense, X and Y are a complement of each other. So if you kind of add them all together, right, then it would always be shaded for all the squares. That's the idea of this relationship between pair. That if X and Y is a pair, then in certain regions, if this part is black, then this part has to be white. If this part is white, then this part it has to be black. So if this is white, this is black, then this part has to be white. If this part is white, then this part has to be black. So let's look at G. On the first row of G, this part is shaded. So out of A, B, C, D, E, which one is such that this part and this part and this part has to be this part and this part has to be black, and this part has to be white. It would be, so that means that this part has to be black, this part has to be black, right? So if this is G, right, this part has to be, the answer has to be this. So we can eliminate A, right? We can't eliminate B, we can't eliminate C, right? B and C is potentially the answer. We can eliminate D, right? Because these two squares here are white. We can E is a contender. Let's continue. In the G, this two is shaded. That means that the answer has to be so if this is 2 is shaded, then this has to be white, this has to be white, so this has to be black. So this eliminates E, right? So it's only now it's like it's B. We can eliminate E. Actually, E is potentially E is could be the right answer, right? So E is a contender. C is a contender, right? So now it's between B and C. Let's go one more row. In G, this part is shaded. That means that this part is shaded. It seems like both B and E is the same. In G, this part is shaded. That means that this part is shaded. So in the very bottom row, this, and this is shaded. So the choice is between B and E. So it has to be E. So let's look at E. So the top row, this two, and this two is shaded. Second row, this and this is shaded. Third row, this and this is shaded. And the fourth row, this and this and this is shaded. That means the answer has to be E. Hello guys, we're going to do problem 13. The length of a rectangle is 8 centimeters. The width is half as long. So let's imagine a rectangle. The length here is 8 centimeters. half as long, the width is half as long as the length, so it has to be 4 centimeters. But this means that the opposite of the longer side has to be also 8 centimeters, and opposite of the shorter side has to be 4 centimeters. The question is, how long are the sides of a square that has the same parameter as the rectangle? The parameter, remember guys, is the length of all of the sides added together. So we are to imagine that there is a square that has the same parameter as the rectangle. So regardless of the length of the square, we know that if all the sides has to have identical value. So if this is L, if this is the length of one side of the square, then it has to be the same as this, the same. They have to be all L's. So the parameter, what's the parameter of the rectangle? Is 8 plus 8 plus 4 plus 4. And this has to be what? 24. 8 plus 8 plus 4 plus 4 is 24. So what is the parameter for the square? Well, since each side is L, then the total parameter has to be 4L. So this has to be equal to 4. This has to be equal to 4L, because we are given that how long are the sides of a square that have the same parameter? How long are the sides of a square that has the same parameter as the rectangle? So the square has to have the same parameter as the rectangle. So that same means that they are identical. So 24 equals to 4L. This implies L equals to 6. Hello guys, we're gonna do problem 14. Thomas has made a table out of small cubes. How many small cubes did he use? So this is the table. So we could imagine that this table is just a normal, regular table. That means the legs are not weird and irregular, that the legs are of identical nature. So the table, the top of it, we can count, well, so there's a top of the table, which is this part. And then there is the legs, this part. There are 4 legs and a top. So we need to add up all the squares. The squares are composed of the top as well as the legs. The legs, each leg would have 1, 2, and 3 squares. And the top is 1, 2, 3, 4. 1, 2, 3, 4. So the top is not a perfect square, I think. One side is 4 squares, and the other side is 1, 2, 3, 4, 5. 5 squares. 5 times 4 is 20. So the top is made up of 20 squares. 4 times 3 is 12. So 12 here on the first. There are 12 legs and 20 squares for the top. So is 32. D. Hello. Let's do problem 15. Three squirrels, Annie, Asia, and Ellie, have collected 7 nuts. They have all collected a different amount of nuts, and everybody has collected at least one nut. So there are three squirrels, Annie, Asia, and Ellie. Cumulatively, they have collected 7 nuts. They all have collected a different amount of nuts, so each of them have different number of nuts that they have collected. Everybody has collected at least one nut. It means that each one has a number that is at least one, right? It could be one or greater than one, but it can't be zero, right? Nobody can have 0 nuts. Annie has collected the least and Asia the most. So there's a ranking on how many nuts each squirrel collect. So each squirrel collect different amount of nuts in such a way that you can rank them, where Asia has collected the most nuts and Annie has collected the least amount of nuts. How many nuts has Ellie collected? So the way I would do this problem is that I would rank them. I would rank the squirrels that collect the most nuts in order. In this case, Asia collected the most nuts, and Annie collected the least amount of nuts. So Ella is going to be in between. So because there are 7 nuts in total, I would try out different possibilities. So suppose that Asia collected 0 nuts. So suppose that Asia collects 7 nuts. Then Ella and Annie would have to collect 0 nuts. But this would violate the condition that each squirrel have at least one nut. So this doesn't work. What if Asia has 6 nuts, collect 6 nuts? Then Ella can collect 1 nut and Annie can collect 0 nuts. That doesn't work because Annie has 0 nuts. It should be at least 1. So this doesn't work. How about if Asia collect 5 nuts? Then that means that there's 2 nuts divided between Ella and Annie. So if Ella and Annie cannot have 0 nuts, then it can only have this distribution 1 and 1. But this would violate the conditions that each squirrel can have collected different amount of nuts. So the amount of nuts that Ella and Annie collect is 1. So they are identical, and that's not possible because the conditionality is that each squirrel collect different number of nuts. So this does not work. Suppose that Asia collect 4 nuts. That means that there are 3 nuts distributed between Ella and Annie. So 2 and 1. This would work. In this case, you have 3 squirrels. They collect different amount of nuts, 4, 2, and 1. Asia collects the most, Annie collects the least, and Ella is in between. And all of them have at least 1 nuts. So this is the right answer. This is the most consistent answer. Ella collect 2 nuts. So it's gonna be B.